Example 1 completed. Now we are discussing about example 2. Right? So what is that question? Once look at on the screen. The question is asked like this. Right? Question is given like this. Here a transparent sphere of radius R. Sphere radius is given as R. And refractive index N is kept air. Whose refractive index is there here? Whose refractive index is N?
Transparent sphere refractive index.
Right. So here it is refractive index of a sphere. Right? Sphere refractive index is given as N here. Okay, the next term. At what distance from the surface of the sphere should a point object be placed on the principal axis so as to form a real image at the same distance from the second surface of the sphere? Can anybody reveal the meaning of question? What is actually asked to find? What are the mediums? How many mediums are there? There are two mediums. One is air and the other is glass medium called transparent sphere. Right? So, hey, here a sphere of radius are kept in the air. So this is, I am assuming, as a sphere. So I have a sphere. Then what actually said here? It is having the radius R. So radius is what? Center to the boundary. That distance is called a radius. So I'm taking the radius as something R, unknown value. Then what said? Point object is kept on the principal axis. So I have to identify its principal axis, right? So principal axis drawn, right? Principal axis drawn. Then here kept in the air is said actually. Here I am going to select the point object at a certain distance on the principal axis, right? Eyes O here. Point object O. Then here to get the image, what type of image it is giving? What type of image is given? Real image. So where do you get the real image? Same side of the object or another side of the object? Another side, opposite side on the screen, right? So here, simply to get the image, I require two rays. One is along the principal axis, right? So here, object distance not mentioned in the question. Actually, here it is asked, at what distance from the surface object be placed? So I don't know that distance. I'm taking the distance as unknown value, something x. X is what? Object distance. So I placed the object at a distance from the sphere or surface is x. So u is equal to x. According to sign convention, we will change it. Then here I am considering the ray. One is along the principal axis and the other is to meet the surface at a certain height. Okay. So here simply where the ray is first, in the medium called air or in the medium sphere? Object. That instant light ray started from air. So refractive index of the first medium is air. Then it is entering into the refractive index N2, sphere refractive index. So second surface is medium by the sphere. So that's why N2 is taken, that sphere refractive index, right? Now what happens to the light ray at this point? It is changing its medium or not? Yes, changing. Then in which direction will the light ray bend? So bending always towards, if it is propagating from rarer medium to the denser medium. So here I need the normal to estimate that. Here it bends towards the normal. So here just you can assume the angle here, then decrease the angle another side. Just take less angle on opposite side. So here on the opposite side, I'm taking parallel. Why I'm taking parallel line here, parallel to the principal axis? Because in our question, it is clearly mentioned at same distance, the image will be formed. Real image, right? So to get the same distance, I need parallel only, transversal concept I am following. Then only it will be reach the principal axis at same distance. That angles must be equal. So that's why I considered parallel to the principal axis inside the sphere. So the ray after first refraction or from the first surface refracting and becoming parallel to the principal axis, on reaching the second surface, again it is changing the medium from denser to the rarer medium. It bends away from the normal. So for that purpose, I am assuming certain angle here. Then that angle will be increased on opposite side. So that light ray bends in downward direction away from the principal axis and reaches the principal axis at a certain point. That will give you image at this point because parallel, sorry, along the principal axis remains undeviate, and the two rays are going to meet each other at this location on the principal axis. So that will be image point for us. That image point I am taken as certain point I. So then the distance between the surface and the image is taken as image distance. Clearly it is mentioned equal to the object in the question. So image distance also same, right? So mathematically, what figure I drawn? What figure I drawn? Is it symmetrical figure or non-symmetrical figure? What I got? Is it symmetrical figure or not? Line of symmetry. Is it? Answer me.
Yes.
Yes, it is symmetrical figure. So here simply that line of symmetry I will show you here at this location. So it is exactly passing through the center, right? So from this, either sides you can see that identical. Is it clear? Is it clear, everyone? Eyes for symmetry, either sides it is same. So I am considering the refractive index of the first medium is N1 and refractive index of the second medium is N2. Here the refraction is taken at this point, right? Object is located at this distance and image will be for the first refraction, where the image will be, how the light rays after refraction from the same point O, they are parallel to each other. See these two. Do they parallel or not? Do they parallel or not? They are parallel or not? Answer me. They are here parallel, right? So this ray and this ray. So they never meet for any extension. So in this case, where your image will be formed, that is at infinity distance. So I am taking for the first refraction image distance as infinity. Image distance is infinity. So object distance u is equal to what? X. Image distance v equal to what? Infinity. Refractive index of the first medium is n1, that is y air. So that we know 1.0003 approximately we will take it as 1, and refractive index of second medium we don't know, it is denser medium, unknown value I am assigning n. Here clear? how I'm considering the values? Give me a response. Right. So here I got the values. Let us take the formula. Which surface we are dealing here? Curved surface. So what formula we need? Curved surface formula. Right. So what is curved surface formula? N2 by V minus N1 by U equal to N2 minus N1 by R. What is N1 value? N2 value here, N1 equal to 1, N2 equal to N. Then what is V? Image distance. How you are measuring? From the surface, you are measuring in the direction of incident light rays. So this is incident light ray, that is towards right side, and you are measuring the image distance also right side. So image distance will be taken as positive. What about object distance? It is towards left side you are measuring. Incident light ray is towards right side. Just a second. Right. So here you are measuring image distance in the direction of light ray. It is taken to be positive. Object distance you are measuring opposite to the incident light ray. So U is taken to be negative. Or these sign conventions are clear. In the direction of light ray, incident light ray, and opposite in the direction of incident light ray. Are you clear how to apply the rules of sign convention? Here you can assume the pole. All must be measured from the pole. In the direction positive, opposite in the direction negative. Always object distance is negative. In any case, mirror or lenses or transparent curved surfaces. Image is real, then image distance will be positive. Image is virtual, then the image distance will be negative. Okay. So like that blindly we can remember. So here apply the rules of sign convention. According to sign convention from the symmetrical figure, I am writing object distance U equal to minus X. Image distance is taken to be infinity. It is positive. Then N1 equal to 1 because it is given by the air. N1 equal to 1 highlighted and N2 equal to N. So image is considered in this case at infinity. Symmetrical figure I am considering. So according to this, I am going to take image distance as that. Right. So now substitute them in the relation. So N2 equal to what? N. Right. V equal to infinity. N1 equal to 1. U equal to minus X. And N minus 1 by R, where you can measure radius of curvature. Also in the direction of incident light ray, the distance between the pole and the center. So it is also taken to be positive. Right. According to that, I substituted in the equation. Then solving. So N by infinity equal to what? What this value given by U? What you can take N by infinity equal to? What the 1 by infinity value?
0.
0. So N by infinity equal to what? 0. So this term will become 0. So what is remaining here? This is only, right? This is only remaining. Then minus into minus will be plus, right? So we'll go for the next step. That is 1 by X is equals to N minus 1 by R. What actually I need to find out? Is it refractive index or the radius of curvature or the object distance? What actually I need to find? See the question. At what distance from the sphere should a point object be placed? So where I placed at a certain point O. What the distance from the surface is? X. So what is X? Object distance. So this is I am finding. So X equal to. So here just simply I will go for the reciprocals on left side and right side. So 1 by X will be written as X, that equal to what we can write? N minus 1 by R will be written as reciprocal R by N minus 1. So what X is actually, here it is object distance. So I got object distance x equal to r by n minus 1. Is it clear? So where you can place the screen? What is your image distance? Same distance, x. So at r by n minus 1 distance will be selected to place the screen to obtain real image on the screen. So this is the solution. Any confusion? Is it clear, everyone? Any confusion? Just look at the screen. That solution is available. So nothing. You will go for example 3. Shall I? Shall I go to next? Yes. So here, example 3. What is example 3 here? See the question. A transparent glass sphere has a small opaque dot at its center. Right? So I'm going for that one. Right? I am observing that dot from outside of the sphere. So this is sphere where that opaque dot is placed at its center. So where is your object? At center only. Right? What is its radius of curvature? We don't know. So that we will take it as unknown value r. At what distance you have the object from the surface? Can anybody? What is object distance here? Which is object? What is object distance? Which is object? Where it is located? See the question. A transparent glass sphere has a small opaque dot at its center. So this is only object. This is only object. Okay. Then does the apparent position of the dot appear to be the same as its actual position when we observe from outside? So here from this position I am observing where I can see the image of the dot at same distance or at different distance. So that we have to find out, right? So here image distance you are finding. Image distance you are finding when we view from outside of the sphere that dot located at its center. So here what surface we are dealing? Curved surface, right? That is what sphere. So where is the object actually? Do you know where is object? In which medium? That means in which medium? In which medium? See that where you are, where the object. You are in a medium air and the object in a medium called glass. Right? Where you are in a medium called air. Where is object? In the glass. So what is your first medium? Where the object is located, that is our first medium. So first medium refractive index I am taking as unknown value n1. What is second medium? That is air, taking its refractive index as n2. Right? Then here finding that refractive index of glass. So refractive index of glass n1 I am taking as unknown value something n. Then what is refractive index of air? We will take it that n2 refractive index as air refractive index 1 approximately. Then what the surface we are dealing? Here we are dealing with the curved surface. So object distance u equal to what? I need object distance. Can anybody help me? What is object distance? What is object first? What is object? Object is opaque dot. Where it is that opaque dot? At its center. So this is object for us. So what is object distance? This is, right? So according to sign convention, R is taken to be positive or negative. What is instant light?
Negative.
Instant light ray direction? Left side or right side from the object?
The left side.
Left side, right? So I will show you that instant light ray direction here from the object. This is instant light ray direction. In what direction you are going to measure? Towards right side from the pole, right? So both are opposite. Both are opposite. So here, if they are opposite, what symbol we can assign? Negative. So U is equals to minus R. Then where will be the image? We don't know. So image distance, I don't know, but I know the radius of curvature R. That is taken to be negative because I'm measuring from the pole to the center. So minus R. Then here, what is V value? I know N1, N2, U value, and R value. What is V value? We have to find out using which formula? Which formula we can use? What the surface is?
Curved surface.
Curved surface. So we can apply curved surface formula. That is N2 by V minus N1 by U equal to N2 minus N1 by R. So drop the values one by one. N2 equal to 1. And V value is V only, unknown. Minus N1 is 1 and U is minus R is equal to N2 minus N1. N2 is 1 and N1 is N by R value minus R, radius of curvature, according to sign convention. Then solving this, you will find out V value. So here I'm transposing this N by minus R towards right side. So here already I have minus symbol this side. On transposing right side, we will get plus symbol, right? So let us transpose by taking 1 by V left side. So 1 by V left side, that is equals to, or multiplication also possible, by that step increases, nothing happens. On right side, I'm expanding this one. So common denominator splitting individually. So minus 1 by R minus N by minus R. On splitting, 1 minus N by minus R, common denominator and splitting minus R and minus N by minus R. So this minus minus will be cancelled, or minus into minus will be written as plus. So N by R I can get. So both sides you have same term. That is what N by R with the same symbol, they will be cancelled here. Right? So what is left? 1 by V is equals to minus 1 by R or 1 by minus R. Then writing the reciprocals. So what we will get? V is equals to minus R. V equal to minus R. What I got image distance here? I got image distance. V is equal to R and with the negative sign. So negative sign, that is indicating us to measure that distance opposite to the incident light ray. So here incident light ray is towards left, right? And your measuring direction is towards right. So both are opposite. We will take it as negative. So object distance and image distances are same and same side. So where you can see that opaque dot. Does the operant position of the dot appear to be the same as its actual position or not? Answer me. According to the sign convention only, you can realize this, where I have to measure. Suppose here, it is your curved surface. So here it is the pole. On the principal axis, you have the center this side. If object is this side, that incident light ray taken left side, you are measuring the radius of curvature towards right side. So R is taken to be negative. So I got image distance with minus symbol. So where I have to measure? Towards right side only. So your object is at r distance and image also at r distance. So both are located at same spot or not? Are you following me? Is it clear? Is it clear? So I got answer is this one, v equal to minus r. So operant position and image position both are same. Object and image located at same distance at center of curvature. So that only I got. Is it clear? Right. So today I'll stop the teaching at this example. After this, we are entering into a new topic. Up to here, I discussed refraction of light only using one surface. After this example, we are going to deal two surfaces. We are going to deal two surfaces for the refraction of light. Any confusion in this topic individually? Surajita,
Sir,
any confusion? Or you feel that example 1, 2, 3?
sir, no confusion.
Okay, once practice that, then it will be easy.
Okay, sir.
Industry,
Yes, sir.
think you ask
No, sir. No, sir.
Mr. Sricharan,
Sir,
any problem?
no doubt.
No
No,
doubt.
sir, no doubt.
Okay. Abhinay?
Sir.
Yeah.
No, sir.
Clear?
Yes, sir.
Maybe you have confusion in the bird problem. Now it is satisfied or not?
Yes, sir. Satisfied.
Right. So go with that explanation only, because in your textbook, just a written explanation is given. Visually not explained. Right? So I am given that visual explanation. Okay, Tejaswini,
Sir.
something confusion to you, mathematics.
Yes, sir.
Yes, just follow it. Okay,
Okay, sir.
follow.
Okay, sir.
Then you will avoid your confusion. Kaushik, how you feel? Kaushik, are you there? Okay, you can learn now. Maybe not available, Kaushik. So I'm ending this class for today.